Okay, let's start. I just went over the course of study. This is MDE 60. It's an intermediate algebra course. Now we're going to do a little elementary algebra. As soon as I go over the syllabus, just to kind of assess where everybody is. What I usually find in this course is that most people don't know elementary algebra well enough to learn intermediate algebra. Okay. So we spent about 3 weeks refreshing you on elementary algebra. Then, if you work hard, people tend to do pretty well with the intermediate algebra. Okay, but it kind of has to work together, and we really have to establish a basic understanding of elementary algebra before we can talk about intermediate algebra. And one kind of moves right into the other. They're like, if there are 10 chapters, the first 4 are kind of elementary algebra, and the last 6 are kind of intermediate algebra. Okay. We usually spend 3, sometimes even 4 weeks on that, but we can't really move to intermediate algebra unless people are ready to do it. We kind of select the topics from intermediate algebra. We select the topics that are most important for understanding pre-calculus. If there's something in an intermediate algebra that isn't very important for pre-calculus, a lot of times we'll kind of gloss over it. We'll concentrate on the things that are most essential for passing a pre-calculus course. After this course, you should, if you pass, and as far as grading, it's pass or fail. It's basically satisfactory, an S or a U. Okay. Not going to pick your point average. So doesn't mean that you really want a U on your transcript. But as long as you do well in subsequent courses, nobody's going to pay much attention to that U. Okay. I can't guarantee that, you know, some people are more picky than others. I'll get a little ahead of myself, so I'm talking about grading. There are going to be 2 or 3 tests, probably 3 tests. Okay. You take those tests in the testing center. You know where the testing center is? And I give you, they're basically in there for a week. You can figure out in your schedule when is a good time to go take the test. Okay. I also give you unlimited time. They're designed for an hour, the first 2 tests. Well, last test is in the final exam. It's designed for 2.5 hours. Although I don't really have to ask that much to test your competence in intermediate algebra. Okay. In a lot of my courses, I do design a full 2.5 hour final exam. Sometimes people stay in there all day. I'm not sure they get much done after the first 2.5 hours, but they'll stay in there all day. I don't think that's going to be a problem in this class. The problems are shorter and more straightforward, not as complicated. So I think you'll be able to pretty much get the test done in the allotted time frame, but if you need extra time, it's there. Okay. Okay. So if you look down the list here, you have the course title and description that I'm not going to read to you. You're in the right place. You probably know what the course description is, but there it is if you want it. Required prerequisite knowledge focuses intermediate algebra, but as I said, we got to do some elementary algebra in most courses to get people ready for the intermediate algebra. Develop the right habits in elementary algebra, then intermediate algebra becomes a lot easier. Purpose of course, prepare you for Math 161 with the co-requisite. Okay. Now, if you do really, really well on this course, I might say, you know this stuff well enough you really don't need the co-requisite course when you go into Math 161. Most people skip it whether I advise them to or not. I don't think I've ever known anybody to pass pre-calculus if they skipped the MDE 61, the support course, when I said, don't skip it. I can tell at the end of this course whether you need that MDE 61 or not. Okay. I might say, I'm not sure. Okay, you go either way, but I recommend the MDE 61. I can say, you're just not ready to do this without the support course. You're not ready to do pre-calculus without support course. You know enough to do it with the support course. It'll fill in some holes that you still have in your knowledge. Okay. Now, if you're in here and if you're in here every day, doing your work, I'm going to see you doing a lot of work. And I'll typically pose a question. Like, first thing I do is I give you a quiz over the homework from last time. So your goal in doing the homework is prepare yourself for a quiz. Okay. You see how you're doing the quiz. And then, you know, generally I'll give you some time to do the quiz, 5-10 minutes, be a short quiz. Then I'll go over the quiz problems. Okay. Emphasizing what I think I need to emphasize to meet your need to understand. Okay, then I'll maybe introduce a topic, give you some rules, give you an example, and say, okay, now here's another problem or another 3 problems, quick 3 problems. I want you to work them. I'll come around, circulate, I'll give you pointers if you need them, and I'll see what you're doing. Okay, by the end of the semester, I'll have a pretty good idea how well prepared you are. Okay. So there are basically 2 ways to pass the course. One is to show me through your work that you're doing okay, but you don't count on that. Okay. This will be a combination of your work and what you do on the test. There's a passing level on the test. If you pass it, it doesn't matter. If your work all looked terrible in class, you pass the course. Okay, you get a satisfactory. If you don't quite pass the test, maybe you're a bad test taker, but I know from your work and from what I see on the final exam and the tests that you are ready to go into the MDE 61 and 161. Okay, I'll give you the satisfactory. That it comes down to my judgment in that case. So don't count on my judgment. Count on passing the test. That's your goal. And then I'm going to tell you in advance whether I think you're whether I'm inclined to pass it or not. Okay. We'll see the test. Think back to what I've seen. And I keep copies of your quizzes. Look back at all that. And I give myself that much flexibility. Bottom line is, if one way or another, I see that you're ready and you're getting a satisfactory. Okay. Okay. Course objectives, learn how to do this stuff. Okay. Now there are specific objectives that I haven't listed here, because they won't necessarily mean anything to you at this point if you haven't had intermediate algebra. Even if you have had intermediate algebra, you might not understand the terminology. I'm not going to explain all that. I'll explain that as we go through the courses. So this is a short version of the syllabus. The long version is online. I recommend that you read through those objectives on the long version of the syllabus every once in a while to see and judge the kind of progress you're making, to remind you of where you are in the course. Okay. Nobody ever does that, but I recommend it. If you're conscientious enough to do it, you're probably more likely to pass the course. But okay, I've talked a little bit about how class generally runs. There's more in writing here. You can read it. I'm not going to read it to you. There's some stuff in italics there that apparently when editing, I forgot to put in regular script. I did a lot of edits to this thing and I put new stuff in italics and then at least intended to remove most of those italics, but apparently didn't. I will caution you about using online resources. I had a course in the last few years. Everybody in the course did pretty much 100% on their homework. Okay. Only one person made over 30% on the exam. What's that tell me? Tells me they're not doing their own homework, or they're doing their homework in a way that deludes them into thinking that they are getting the right answers. Like you have this online tutor, you say, how do you solve this? And you copy down the steps of the solution, okay? And that doesn't get you where you want to go. You know, if you do that, you're gonna, if you're into class, you're gonna come into class and I'm gonna see you don't know how to do anything. I'm gonna see you made 100%, see you don't know how to do anything. I'm not gonna call you on it. I'm just gonna help you as best I can and hope that you somehow pull it together, okay? If you're doing stuff inappropriately, that's on you. And I'm not gonna police it. That means, of course, that you can easily make 100% in your homework. Homework only counts 10%. You don't pass your exam or come real close to passing your exam, that homework is going to get you over. Oh, and you don't want to just pass. You want to do well in this course. Pre-calculus is a tough course. You got to know this stuff well. Okay. All right. So learning style I recommend that you use is you learn to do stuff. You read the text, you look at the examples, you do what we do in class. What we do in class should prepare you pretty well to get a good start. Okay. You go to an online tutor and ask them how to tutor you in the subject. Don't ask them how to solve your homework problems. Okay. You can ask AI, ChatGPT or whatever. Can you give me some pointers in solving this kind of a problem? I don't quite understand it. Tell them what you do understand, what you don't understand. It'll probably give you some pretty good stuff. You don't know. It does some bizarre stuff. So you don't totally trust it. But most of the time, it's probably pretty good. Not to the point that I recommend it, but people are going to use it. And for the most part, I think it's probably okay. But don't use it with your homework problems. Use it for examples, use it to understand the topic. And tell me how you're using it. You know, I'm not going to say anything bad to you. You might want to think about doing it this way or that way. Okay. That thing that astounds me is people don't see anything wrong with just going online and getting the solutions and copying down, not learning anything. That's insane. If you want to pass the course. Okay. I have trouble with the idea that people have that illusion. I'm not sure where it comes from, but I'm not sure what to get in the prerequisite courses. Okay. So I think we've got most of that. I do want to see your written work. I don't want to see you just doing the work in front of a computer without writing stuff down. Okay. So I want to see your solutions. And I say get a dedicated notebook. Do your homework in an organized fashion. Doesn't mean you can cross stuff out, you know, you cross a whole page out and do it in the next page. You know, it's a work in progress, right? Just show me what you're doing. Because I want to look at that every day. Okay. Even if the example I used, I went through all this stuff earlier, not realizing that we were on snow schedule, and that's when nobody was here. Okay, well, everybody's here at that. That's wonderful. I lost my train of thought. What was I going to say? Well, Uncle does. There is a thing here, it says written documents must be submitted by VHCC email. Okay, that's whatever's in your notebook. You can scan it if you got a scanner app, any smartphone, download a scanner app. In a few seconds, you can scan it and send it to me. Okay. Alternatively, you can go to the library and copy it or use a copy if you have it. But I want to have a copy of it. One of the reasons for that is this course is in development. If I have those copies, I can trace what people are learning through the semester. And use that to help me modify the course for the next time. But also, it's mainly so I can take a good look at your work if you're having a problem and figure out how to help you. Gives me a valuable tool. You can read the details, how that needs to be done. If you email me from your VCCS account. Okay. Don't email me from Canvas. I mean, I'm not gonna do anything to you if you do. I'm just gonna say, next time email me at this address or email me from your VCCS email. That's not Canvas. Canvas email is a mess. I can't find anything in it. I can't search anything. And attachments take 10 steps to open. Whereas if you email me from your VHCC account, VCCS account, one click and I see your attachment. Okay. So I'm not going to mess with it. Send me an attachment through Canvas. I won't go for it, but I will email you saying, hey, send me this the way you're supposed to. Okay. Just send me this, please send me this through your VCCS email. And don't send anything through your personal email account. Okay. Because I can't trace it. I can't search it. I'm not going to search 3 different places to find your emails, right? And I won't take the time. I can't take the time. Okay. Class doesn't start until 1:15. But you're welcome to sit in here and learn some elementary algebra. He's taking multiverbal calculus. So he's way down the road from elementary algebra. So, okay. Okay, then you will need a calculator, but not to do algebra and stuff. Here, use online utilities, online calculators, but don't do the algebra with those things. First place, well, just what I said before, it's an inappropriate use of technology in this course. Okay, if you got a disability, you might need some sort of accommodation. Usually the accommodation would be, you need extra time on tests. But since I don't put time limit on tests, that's not an issue. If there's another accommodation, please let me know in case I missed it. Other thing that I missed in this thing is something about course videos as distributed on DVDs. If you see that, ignore it. Okay. Videos are posted through YouTube. So I got to take that out of there. There are specific objectives. As I say, those are things you need to read. The open math course for the open math page for the course includes textbook. It's online. Along with the idea that you ought to be writing things out. It's the idea that it would be good to have a printed textbook. Okay. I don't think I made arrangements to get a printed textbook for this course, but I'm gonna make myself a note.
Just don't use AI to
See if I can make that available. Okay. Grading policy. It specifically says you pass by attending at least 85% of class sessions, actively participating in class activities, and scoring at least 60% on each test in MDE 61. Okay, then it says things that I've already said. Use of email is, again, as I've said it. Attendance policies, the college attendance policy says attendance is required. Well, it's mainly required so you learn the stuff. So be here. Okay. If you're not here, let me know. So don't worry about you. I mean, if you're not here, I'll find out about it, but let me know in advance. Don't worry. There's another statement about students with disabilities. Read them both. They both apply. There should only be one, but looks like I've got two of them. They're both. But the second statement tells you who to contact and where. He's right there about 50 feet in that direction. You just go through that wall, count 50 feet. Probably go through the women's bathroom if you go that way, so you probably better not. Yeah, well, you can't get there. You have to go around the hall, but you end up right about there. So the details of how to contact these people and so forth are right there. Academic policy and academic integrity. If you cheat, you can get in trouble. You can read the details. Okay. It's going to be hard to cheat in this course. You know, if you use ChatGPT to do all your homework, it really is cheating, but I'm not going to police that. I'm not going to make a judgment whether you did that using ChatGPT. I wasn't there. You weren't under supervision. Okay. I say ChatGPT, any AI, any inappropriate method. Okay. So I'm not going to accuse you of cheating if you make hundreds in all your tests and 30s on your test, hundreds in all your homework and 30s in all your tests. Okay. I'll know that you probably did something inappropriate. I'm not going to hold it against you because you're the ones being punished when not learning material. Okay. And you really can't cheat in the test next time. If you figured out a way, well, I'll kind of be able to recognize it, even though I can't prove it. I won't accuse you of it. But I'll go talk to them and say, how do you think this happened? I haven't had to do that in 15 years, but you know, they're pretty much on to stuff. Okay, you got stuff about college-wide emergencies. You got the link to the college website, VHCC alert system. Instructor's email. It says something about the Blackboard supervised study site. That should have said the Canvas site. We got rid of Blackboard, good riddance, back a few years ago, but we got Canvas, which we it's actually in some ways almost an improvement. I think the main reason we got it is because of privacy laws. More general information about the emergency situation. You got the VHCC website, you got the VHCC phone number, and you got the emergency text or phone system that you can sign up for, and it gives you the links where you can sign up. Okay. So if you need to know that stuff, would have been good if I'd have signed up before. I wouldn't have been here an hour early. I probably would have been anyhow. Had stuff to do. Got VHCC deadlines. Today's the last day to add a class. That'll probably be extended a little bit because we missed most of the last week to weather. Last day to drop a class or receive a refund is a week from this coming Friday. That probably won't be changed. I don't. I don't make that decision. I might change it. And last day to withdraw without academic penalties, April Fool's Day, but if you withdraw it, we assume you really mean it. Even though it's April Fool's Day. Okay, because you can't really get back in after you withdraw yourself. There's no good reason to withdraw from this course, I don't think. I don't think a W looks any better or worse on your transcript than a U. Okay. But maybe it does, so ask people. But I think you need to stay in this course, even if you're not on track to pass it, you can still keep learning stuff. Learn everything you can, you know, this course has been paid for, you're here. You're available. Teach as much as we can, and if you have to repeat it. And usually people have to repeat the course because they didn't put enough work into it, or did the work the wrong way. It can take a lot of work though, so be prepared for that. And you got to do an Algebra 2 course in essentially about 10 weeks, okay? It's usually a year-long course. Or most of an Algebra 2 course. You got instructions here on the withdrawal policy, how to withdraw from the course. It gives you step-by-step instructions. I'm not going to read them to you. They won't mean anything to you until you get up to the point where you need to do that, and hopefully you won't. We've got tutoring services available through BrainFuse 24 hours, and then in-person tutoring through the tutoring center. You know where that is? It's in the library. Just go up to the front desk. That's what the tutoring center is, the Mark Moose Academic Resource Center. We do have mental health support. You don't have to be completely crazy to need mental health support. If something's going on in your life that's interfering with your studies or with anything else, sometimes it can help to talk to somebody, get a little help. Okay? No shame in that. And nobody's going to tell anybody that you're doing that. So we've got the 4 people. They're here, over to there, in the next hall on that wall. Okay? And you can talk to any of them. And I'll give you their email addresses. Okay. So that's half of this no schedule class. So let's go ahead and do a little bit of math. Now, we did similar stuff in the MDE 61. And I've actually posted that at your website. So you might want to take a look at the examples we use there as well if you don't understand everything we do there. But this will give you a little idea how the class works. So I'm going to put a few problems on the board. And I'm going to pause the video because you're watching the video. You don't need to watch me write the problems. They'll be there. Hold on a minute. Okay. So I get 4 problems. I want you to work these as best you can. And one of them, almost nobody ever solves correctly. Okay, so if you miss something, you're not alone. So we do these. And also jot down what rule you're using. If you don't necessarily need to know the name of the rule, you know, that rule where you do this or that, you know, there's some indication of what rule you think you're using. And I'll work them here in a little while and tell you what rules get used. Okay, now, first place, if you're a distant student watching this, or if you missed class and you're watching this, you should have stopped when I posed these problems.
Yeah.
Work them, and then look at what I'm about to do. Okay. Now people have already solved these, so I'm going to go ahead and do it. But if you haven't worked these problems, pause your computer now and work the darn things best you can. That's known as engaging yourself. Okay, if you're watching a video and don't engage yourself, you're not going to learn much. You don't learn by watching, you learn by doing. Okay, you multiply this. Well, when you multiply fractions, it's very simple. You multiply the numerators. And you multiply the denominators. Okay, now when I say state what rule you're using, you might not be able to state that, but if you show me this step, then I'll know what you did. Okay, now if you think you're doing something else, write out what you're multiplying up here and write out what you're multiplying down here. Okay. Then I can tell clearly what you did anyhow. That gives you 10/27. Okay. How do we add two fractions? Well, how do you add thirds to ninths? If you know how many thirds you got, then you can figure out how many ninths you have. Okay? If I've got 2/3, how many ninths are there? Well, it takes 3 1/9 to make 1/3. Yeah, you don't really have to know that, but it's worth kind of thinking about to get your thinking on a little higher level. The way we do this is we use a common denominator, which will be 9, since 9 is a multiple of 3. So officially, we multiply 2/3 by 3/3, which is just 1. Okay. And we're going to get an equivalent fraction. It has 9 as a denominator. And then we add 5/9, and we get 6/3 plus 5/9. That's 6/9 plus 5/9. Okay. Now we know how many ninths we got here, how many ninths we got here. Okay. How many ninths do we have here? Show me with your fingers. Hold up as many fingers as we have ninths. How many ninths? 6 of them. Right? Now, how many ninths do we have here? So what do you get if you add 6 of them to 5 of them? You don't have enough fingers, you get 11 of them. Okay? Now, a lot of people make the common error of adding the numerators and adding the denominators because you get confused with the rule up here. Okay, we might do something even worse. Okay, well, if you're doing something that isn't right, fix it. This is fairly easy to fix. And of course, your first assignments are going to be on fractions. We just start with fractions. That's not even elementary algebra. That's 5th grade arithmetic. So don't feel bad because you don't know 5th grade arithmetic, because nobody else does either. Okay, you're part of a huge majority. 90% of people learned it in 5th grade and never had to use it again because people put calculators in their hands or online resources. It's ridiculous. And it gets in your way in pre-calculus just when things get really hard. The hardest thing might be adding algebraic expression instead of numerical fractions. If that's x squared plus 8x plus 2, and that's 5x cubed minus 13x plus 7, and that's something else and something else even uglier, you know how to add them? Not if you don't know the rules for adding numbers. Okay? But if you know the rules for adding numbers, it still isn't that easy, but you have a basis for being able to do it. Okay? That's one reason that we really need to understand fractions. Another thing is we kind of need to understand 2/3. Is 2/3 bigger than 1/2 or less than 1/2? This for bigger, this for less. Okay? It's bigger than 1/2. Okay?
Yeah.
Why is it bigger than 1/2? Well, here's the picture. If it's 1 unit between these, and you divide this into 3 units, then each of these is 1/3. And you've got 2/3. 2/3 is 2 1/3, so here's 2/3. And it's more than half, right? What about 5/9? No. Let's say I'll divide this into thirds, and then I'll divide each of these into thirds. And they're divided into ninths. I count over 1, 2, 3, 4, 5 of them. Here's 5/9. And here's the other 4. 5/9 is bigger than 4/9. 5/9 and 4/9 spans 1, so 5/9 is more than 1/2, right? So we can conclude this is more than a half, this is more than a half. So when we add them, we get more than what? Well, if you add a half and a half, what do you get? You hold up fingers. Take half of something and add the other half, you get the whole thing, right? Half and a half is 1. Okay. So if half and a half is 1, then something bigger than a half added to something bigger than a half is bigger than 1. Okay. So this has to be bigger than 1. Of these pictures, if you add this arrow to this arrow, if the ones are on the same scale, you get something that goes past 1. Okay. So you add the numerators and you add the denominators. This is less than 1. The sum has to be greater than 1. Okay. Two-thirds plus 5/9 is greater than 1. And 7/12 is less than 1. If you add 2 fractions that are both greater than a half, there's a very good chance that if you use this rule, you're going to get something that isn't greater than 1. It's just, and it's almost never right. You have to go a long ways to figure out a set of fractions that you could add that work out if you add the numerators and add the denominators. Okay. Yeah, 1/2 plus 1/2 would. So avoid this. Completely wrong. Okay. Now, this illustrates the idea that I want to encourage you to think about why things work and why they might not work. Okay. If you understand why it doesn't work to add the numerators and add the denominators, then you're going to be less likely to add the numerators and add the denominators, which is what I see from a majority of students that come into pre-calculus. Okay, much less majority of students that come in to this intermediate algebra course. Okay. Okay, 5x equals 17. How do we solve that? Simple enough. We divide both sides by 5. 5 divided by 5 is 1. And that leaves us x here. Now that's actually 3 2/5. And if you want to put that on a graph, you kind of need to know that it's 3 2/5. So the mixed number result is not without its uses, okay? If you want to position it on a number line, you kind of want the mixed number. But as far as just getting the solution, unless I ask for a mixed number, or unless you need to graph it, then this is perfectly okay. Now, I do want to see the fraction. Okay. If you want to say, okay, that's also equal to 3.2, that's all right. Of course, no, it isn't, because it isn't equal to 3.2, it's equal to 3.4. Yeah, okay. So if you want to calculate the decimal, that's okay. If you want to use a calculator, you calculate the decimal. You know, if it was 173 over 68, I don't expect you to do long division to figure that out. That's where it's appropriate to use a calculator. But don't say it's 3.4 without telling me it's 17 over 5. Because when you do this stuff with more complex expressions, if you do this kind of thing with formulas, there's no such thing as a decimal equivalent. It's a numerator and a denominator, okay? So there are reasons that we want to see the steps, and this is what I want to emphasize. I don't want to see the answer is 3.4. Well, if you're fairly good with algebra, some of you appear to be, you probably do that in your head. Don't do it in your head, write it out. Okay, even if you know how to do it in your head, write it out, because it reinforces the steps. Now, there comes a point when you don't need to reinforce the steps, but most people think they know more than they do and stop writing out the steps before they really are. So everything I see you turn in, I want to see all the steps, and I'll point out when you don't have them. And emphasize, here's what you're reinforcing when you write out the steps. Later on in the course, it'll be your benefit. And you'll also remember it better. Okay, 3x plus 4 equals 16. Well, I'll write it out again, but I leave myself a little space, because what I want to do is I want to subtract 4 from both sides, which gives me 3x equals 12. I don't like this thing of writing 3x plus 4 equals 16 and then a 4 down, a minus 4 here and a minus 4 here, and then you write this out, even though a lot of time people get it right, because I keep seeing people get confused by doing that. I prefer to see this, but as long as you're not making mistakes, you can do it the other way, because it's not invalid. Okay? I just kind of caution you. I don't think that's the best way to do it. Don't really have room to write it underneath here. But then we have 3x divided by 3 equals 12 divided by 3. So that x equals 4. I want to see those steps. Make sense? So let me ask you a little time. About 8 minutes. 7. And I'll leave this up here where you can see it. No problem, so just go ahead and start on this one. And maybe use some of this. Hopefully, we refresh your memory a little bit. And of course, we're going to cover this. I know there'll be an assignment fairly shortly. We have open math and open math videos and everything I can do for you. And the textbook. And we'll get straight on some of these rules. All of them, as far as that goes. And I've seen a variety of things. I've seen people trying to do this. And then they add this -3 to this -3, or maybe it's a +3, which will get rid of that 3, except that that 3's got to be multiplied by 2. This 2 says multiply all this. Okay? Another reason I don't like CDS. Okay, I don't forbid it. If you get it right, okay. But I think you're less likely to get it right than if you write things out in linear fashion. Doesn't mean that open math videos don't sometimes do stuff that I think is wrong too, and yeah, they can be right. Okay. Now, one thing that is valid, you could divide both sides by 2 here. You know, the 2 would divide the 2 here, the 2 would divide the 24. So that would be a valid step. That would leave you with 5x minus 3 equals 12, which would then be fairly straightforward to solve. Wouldn't be a bad approach. I want to illustrate the distributive law. So 2 times 5x is 10x. 2 times 3 is 6. So 2 times minus 3 is -6. The 2 has to multiply everything in here. That's your distributive law. Then, doing this kind of quickly because it's about out of time, add 6 to both sides, because I can now do that. That 6 isn't mixed up with anything else. Okay. And I get 10x equals 30. So that x equals 3. And then I go back and check this. I plug that x equals 3 back into the original equation. And I get 2 times 5 multiplied by 3 minus 3 equals 24, which is 2 times 15 minus 3 equals 24, which is 2 times 12 equals 24, which is 24 equals 24, which checks out. And this checking step is the difference between learning it and not learning it. If you always check it, you always know when you made a mistake, and then you can go back and see what you did. And you don't have to wait 2 days, 5 days for me to see your work and say, no, look what you did. Okay. You check it. Now, if you check it and keep trying and so forth and it doesn't work, then that's a good time to email me. Hopefully with a copy of your work, but one way or another with some description of what's going on. Okay. Okay. Now over here, I'll just solve this real quickly without comment. Multiply the 3 through here, you get 6x plus 15. Multiply the 4 through here, you get 12x minus 28 plus 6. Add the minus 28 and plus 6, you get 12x minus 22. 6x plus 15. Then subtract 15 from both sides. And you get 6x equals 12x minus 37. And then you subtract 12x from both sides. And times 12x. And you get negative 6x equals negative 37. Negative 6x over negative 6 equals negative 37 over negative 6. So that x equals 37 over 6, and we don't have time. And I can't even guarantee that it was right, but we checked this, it's plugged in for x. Check it out. Okay. That's how we do algebra. Now, next week, you'll probably have learned the rules well enough to do all that. Actually, we don't get to linear equations till a week from today. But then we do the linear equations. That day and the next, okay? Okay. So we've got some work to do. But y'all have a lot of the right instincts. You're doing some of the stuff right, and some of the stuff, we just got to get the rust out and make sure we focus on what the rules are. Fair enough? So start by doing the homework, which is really simple. Okay, you have the introduction to My Open Math, which is due tonight. Gonna take you, I mean, if you haven't been to Canvas and everything, but I think you have, because everybody here, I think, is registered. This section, okay? I think is everybody in Open Math? I think so. I mean, I didn't look at the Open Math grade book or roster, but I did look at the SIS roster and everybody's registered. So you've done well. Maybe you've done the introduction by Open Math. And you haven't checked the homework. It's due tonight by 11:59. And then due on Wednesday is the first assignment of fractions, and it's pretty easy. So it's not gonna strain you, but get used to the My Open Math, and then we'll start straining you. Okay? But hopefully we won't strain you beyond your capacity.